More bubbles.
Dennis, you want to explain what's going on here?
Sure. So what we did in the experiment is we actually made snow here in Texas in July. Okay. And what we did is watch it rise and touch the bottom of the aluminum, and you got a layer of frost on top of that aluminum. And we're demonstrating how lithospheric plates actually thicken as they cool. Okay, and ultimately get thick enough so that they can sink back into the mantle. What we're demonstrating here is at the end we all play, and we take that dry ice or CO2 and put it in the water, and it basically sublimates, and it's cool. So what you're seeing is a true cloud. So you're actually seeing the water vapor condense out just like it does in a cloud, and it looks white just like it does if you're in a cloud. Okay. And then that cloud dissipates as it warms because the warm air can hold more moisture. I thought you'd enjoy filming.
Yes. I'm over here playing.
So we started a whole nother experiment over at the
Oh goodness, a whole nother one.
So they're watching how fast it drops.
Not that fast, apparently.
This one's pretty much staying at, it's about 16.
Why do you think some of the mantle becomes solid and freezes on the floating crust? Remember the floating crust of oceanic crust above it is in contact with ocean water, which is 29 degrees Fahrenheit. Right? So it's really, really cold. And remember the mantle is
So solid.
especially where it's liquid, is about 1200 degrees centigrade. So here's this really hot stuff and the cold stuff above, and heat rises, as you know, right? And it has to be dissipated through that crust. So, and as it loses that heat, things start freezing on the bottom.
So why does it?
Just like that frost freezes on it. So the steam coming off of it is basically the stems for the semi-liquid mantle. And as it loses heat to it, it actually starts freezing onto it. And remember the freezing part, the part that's freezing on is solid and therefore more dense than the oceanic crust, right? The oceanic crust is less dense though. And so it floats, but as you freeze more and more mantle on it, that mantle is more solid than the semi-solid mantle, so it actually gets heavier and heavier and heavier, and it starts dropping and rides lower and lower and lower until a certain point. And at a certain point,
But it
actually
does now.
becomes effectively more dense when it's floating. And when everything's more dense when it's floating, it sinks. Right? So this is the reason that the oceanic crust actually subducts. Why does it sink? It's not only because it's slamming into things, but it's also just because it's getting heavier and heavier, and at some point it just literally sinks. Right? And what you're going to do on the next thing is calculate out how long it takes to actually sink. Right?